Hello and welcome. In this video, we're going to be solving yet another pure question. However, today it's a pure 2 question. This is the 9709 Cambridge, paper 21, 2019, and this is question 6. So let's start by reading the question. This looks like a trig question. These are always confuses students. So the question just says basically, showing all necessary working, solve the equation secant alpha cosecant alpha equals 7. Whenever you have any trigonometric equations that you need to solve, the thing that you need to think about straight away is using the ASTC rule. And this rule is the easiest rule to solve the most complex trig equations. And I will leave a link to a video that I thoroughly went through ASTC rule with lots of explanation and lots of examples, so you can follow along. I'll leave a link to it on the top right hand corner. Please feel free to go and check it out. Okay, so always in these questions you'll be given a range of values, because you know trig equations, just like a function, or like trig functions like sine, are never ending. They're gonna keep on continuing like this forever. So we need to put in a range of x values, or like theta values, that okay, we're looking for solutions only in this range, and this is denoted by this range over here. That's why always these questions are going to be having some sort of range with them. Okay, so secant and cosecant alpha. First, I know that secant alpha is equal to 1 over cosine alpha, and I know that cosecant alpha is equal to 1 over sine alpha. So I'm gonna start by writing them this way, and I've found like a common trend that always whenever you have questions like these and you want to solve, at the end of the day you have to reach to something where it has only one trig function. Like we want to narrow down this all the way into sine of something equals blah blah blah, and then start to solve. However, when it's something like this, we cannot solve straight away. So the process of reducing this into a single sine or a cosine or a tan function can be tricky, okay, and it requires practice, and it requires knowledge of trig identities. So one trick I found that is something that's common to use in all questions is to start by trying to change every single non-sine, cosine, tan function, like secant, cosecant, if I have cotangent, blah, blah, blah. First thing, I start to change all of them to sines and cosines, and then sometimes I find things that are cancelling with each other. Even tan, if I have a tan x, I will usually try to change it into sine x over cosine x, and then maybe there is a multiplying cosine x. So let's say if the question was cos x tan x, this is going to be sine x cos x times the cos x. These will cancel and you will end up with sine x only, which is what you want. So this is a tip that feel free to follow, but I find super useful. So this is exactly what we're going to do here. We're going to change secant alpha times cosecant alpha into the respective sine and cosines function. So secant alpha is going to be 1 over cosine alpha multiply. Alright, so it's 1 over cos alpha times 1 over sine alpha, and this is equal to 7. So basically, let me get rid of this. So this is basically just 1 over cos alpha times sine alpha, right? I will multiply this cosine alpha to this side. I'm going to bring the 7 to that side. So it's going to be 1 over 7 equals cosine alpha sine alpha. Now from here, to move from here, we need to take a look at the trig identities that could be helpful. So I have this, I have this page printed or like shown in the whiteboard over here. It has all the trigonometric identities, and don't worry, you won't be needing all of these. If you want, I can you can send me and I will send you a smaller one where basically all the identities you need for pure. But basically we need to try to find something that has a cosine alpha and a sine alpha. And from here I can see that in the double angle formulas, sine A times cosine A times 2 is equal to sine 2A. So basically I can rewrite this as sine A cosine a equals, I'm going to divide both sides by 2. So this is going to equal sine 2 times whatever a was over 2. So I can use this over here. I can see that I have a sine something multiply cosine, the same thing. So I can change it into this form over here. So this is going to stay 1 over 7. And this is going to equal over 2 times sine of 2 times whatever that was there in the beginning. So 2 times alpha. Sorry, 2 times alpha over here. Now I can take this 2 multiplied to the other side. I'm going to have 2 over 7 equals sine 2 alpha. And now I managed to reduce my trig function into something where I only have sine of something inside it equals 2 over 7. Now the trig formulation or the trig manipulation is ended. We reached what we want. So now we go into the second part of solving this, which involves the ASTC rule. However, in the ASTC rule, I don't like to see any coefficient multiplying my x or alpha or whatever. Yeah, I don't like sine of 2 alpha. I don't like to see sine 30 plus alpha. All I want inside is just sine something x. So let's see how we can change that over here. So I know that the range is 0 to alpha into 90 degrees. So alpha is in between 0 and 90 degrees. However, what's inside here is 2 alpha. So what I'm going to do is I'm going to make this exactly the same as what's inside. So basically multiplying by 2. So this is going to be multiplied by 2. And since I multiplied by 2 here, I need to multiply by 2 on both sides. If I added a 30 here, I will need to add 30 on both sides and so on. Whatever you do in the middle, you need to copy basically and paste on either side. So this is going to be 90 times 2, which is 180 degrees. And this is going to stay 0. Because 0 times 2 is 0. Now, 2 alpha, I'm going to call it, let's come over here on the side. Let me just call 2 alpha as something else that is just a single thing, like a big X or something. Okay, so this is basically 0. And instead of 2 alpha, I'm just going to call it something else, which is X and till 180 degrees. Okay, and from here, I know that if I want to find alpha, I basically do X over 2. We're going to keep this for later, and I'll show you how we will use. Now, what we have over here, I'm just going to write this on the left side. It's going to be sine, instead of 2 alpha, is going to be X equals this, which is, what happened? All right, continuing, this is basically going to be equals to 2 over 7. Now I will need to solve within my range, and this is where the ASTC rule comes into play. And as I said, it's super important and good to know how to use it. So I'm going to go through with it with you over here in this video. So I have A, S, T, C. A stands for all. S is basically sine. This is all. This is tan. And this is, you can guess it, cosine. Okay. What I do over here, okay, is that I need to look at what is on the right hand side of my equation. Is it a positive number or is it a negative number? Here it's a positive number, right? So I need to find the quadrants where sine is positive. We have 4 quadrants. I need to find the quadrants where sine is positive. All stands for all positive. Sine stands for sine is positive only. Tan, here only tan is positive, and in this quadrant only cosine is positive. So which quadrants will sine be positive is going to be in the all quadrant and in the sine quadrant. So I'm just going to go and draw 2 lines in these quadrants over here. I'm going to keep them right over here. So in the normal way, if I want to find what is x, I'm basically going to take sine inverse of both sides. So x is going to equal sine inverse of 2 over 7. If I put that on the calculator, shift sine 2 over 7, that's going to give me around x equals 16.6 degrees. Okay, now this is my first solution. Okay, in the ASTC rule, I need to show this solution. How do I show it? First, we always, from the ASTC rule, we always start from the positive x axis. We start from here. Okay, if we move counterclockwise, that means we're moving in the positive side. If we move counterclockwise, it's in the negative side. So my answer was positive. So basically, my first solution will be me starting from the positive x-axis and moving positive 16.6 degrees. So 16.6 degrees in the counterclockwise direction. So this is going to be 16.6 degrees. And by symmetry, this angle over here also, just the magnitude of this angle is just going to be 16.6 degrees. And that's going to help me finding the rest of the solutions. So the solutions, I find them by starting on the x-axis and moving until I hit one of my lines. Okay, so the first solution was already done. We know that this is going to be 16.6. The second solution is going to be me starting from the x-axis and moving counterclockwise until I hit my second line. So this whole angle is going to be my second solution. And this angle, I can see that this whole part is 180. If I remove this small part, it's going to give me the angle that I want. So my second x is going to be 180 minus 16.6, which is basically 163.4. So I can erase this and just write 163.4 degrees. Let's see a third solution. So a third solution, you can start from here. Go, this is the first solution we already have done. Second solution already done. We move until we hit this line again. This is first time I do this revolution and hit it again. So I can see that this angle is a whole 360 plus this small part, which is 16.6. So this is going to be 360 plus 16.6. That is my third solution. It's 376.6 degrees. However, my restrictions for x just tells me that x is just between 0 and 180 degrees. So I'm not going to take this as a solution. That's how I know that these are the only two solutions that I have. Also, we can find the negative solutions. If you start from here and move the other way around, okay, this is a whole 180 plus 16.6. So 180 plus 16.6, that's 196.6 in the negative direction. So an x value also would be negative 196.6 degrees. And if you put on your calculator, if you try now put sine negative 196.6, it should give you 2/7 basically. That should give you the answer, or 0.28 something. You change it to decimal, it's going to be the same. So these are basically how to find all the solutions. The only restriction you have is your range. So the only two values or solutions that will satisfy our range are these two values. Okay, so these are the x solutions. Type, are we done? Did we solve the question? No, because the question says solve for alpha. Okay, we solved for another variable called x. However, they're related. See, I told you we're going to come back to this part over here. So if I want to find alpha, I basically divide my x over 2. So 16.6 over 2, that's going to equal 8.3 degrees. Okay, that is my first proper solution. And alpha equals 163.4 over 2. That is going to be 81.7 degrees, and that is my second solution. And if you want to try, you can put in alpha over here. You can change alpha with one of the solutions, let's say 8.3. So you put secant 8.3 times cosecant 8.3, or if you want it in terms of cosine and sine, you do 1 over cosine 8.3 times sine 8.3. Let's double check. So 1 over cosine 8.3 times sine 8.3. And if you put that in your calculator, your answer is going to be 7. That's how you know you've solved your questions and you've stayed within your range. Okay, the range is from 0 to 90, and our two values are within that range. Guys, believe me, ASTC is huge. It's a very, very good tool to use to solve, even if you're going to go into engineering. Please go check it out. It's very, very important. Now, this question has a second part to it. I can just erase this part over here. Okay, let's try. It's a similar idea, so I like to have lots of ideas of the same type in one video, so you guys have more practice. This question again tells me solve for b. but for this equation over here, sine b plus 20 plus sine b minus 20 equals 6 cosine b, and for this range over here. So again, I'm going to go back to my formula, the identities, and try to find something that would be helpful. So I know that I have sine something plus something and sine something minus something. So let's see what can help us, okay? So it looks like the difference of two angles and the sum of two angles are very similar to what we have. I have some sine something plus something, and I have sine something minus something. So let's try, just try. By the way, you have a lot of trial and error in questions like these until you find something that works. So let's try these two things. So basically, I know that, let's write them down and copy them over there. I'll do that. Yeah. So I wrote down the identity, which goes like sine A plus B is sine A cosine B plus sine B cosine A, and so on. So let's first start by changing this first term over here, which looks very similar to this term over here. So I'm gonna have sine B plus 20. So A is basically going to be the beta, and B is going to be the 20, right? So this is going to equal sine A, so sine beta, times cosine B, which is 20, plus sine B, which is 20, times cosine, the first term, or the first letter, which is beta. Okay, this is the first term over here. I change it into this. Let's now add, let's now do plus, this plus over here. I'm going to do a plus, and then we're going to do the second term. However, this second term looks like this, so I'm going to follow this identity over here. So again, the beta is the A, and the 20 is the B. So now sine A, so sine beta, cosine B, which is 20, and then I will do a minus sine B, which is the 20 degrees, times cosine A, which is the beta. So now I change this term and this term using the identities, and they're all equal 6 cosine B. So let's see how we can simplify over here. Straight away, I can see that I have minus sine 20 cosine beta, and I have a sine 20 cosine beta. So sine 20 cosine beta minus sine 20 cosine beta, they basically both will cancel. And I can see that this term, sine beta cosine 20, sine beta cosine 20, they are the same term and they're added together. So basically x plus x is 2x, or this term plus this term is basically 2 times sine beta cosine 20. That is equal to 6 cosine beta, and I can just divide the 6 and the 2, so this is just gonna basically be 3. Okay, now I reached to this over here. What I can do is, first of all, this cosine 20 is just a number. It's just, you put a cosine 20 on the, it's just similar to like 4 or 40 or 79 or negative 200. It's just a number, okay? So it's like 2 sine beta. It's nothing to worry about. However, I have a sine and a cosine of beta over here. And as I told you, I always want to have only one trigonometric identity to start using my ASTC to solve. I know what I can do is, I know that tan x equals sine x over cosine x. So if I divided both sides by cosine beta, I will have this part, which is sine over cosine. So this part is going to be tan of beta times cosine 20 equals 3. And now to make the tan beta alone, I will divide both sides by cosine 20 over cosine 20. So over here, my final simplified and manipulated equation is going to be tan beta equals 3 over cosine 20. Now from here, I can start to solve very similarly to what I've done before. So first of all, this is already beta. It's not 2 times beta, or it's not beta plus 30. So no any manipulation or naming a different variable. Remember when we named the x variable over here, we named alpha to, or to alpha to x, and then we change the range. We don't need to do all that hassle over here because it's already just beta, like how we like to see it. So now I'm just gonna draw my ASTC rule. ASTC. The second step is always to look at this value over here. Is this number a negative number or a positive number? It's a positive number, so I need to see where the quadrants where tan is positive. Tan is going to be positive in the all quadrant and in the tan quadrant over here. So I'm going to draw my two lines. I'm going to start by finding my first solution. Beta equals tan power negative 1 of 3 over cosine 20. You can put it on the calculator. You will get a decimal. You will round it. However, I prefer to always leave it like this to make sure it's as accurate as possible, because if you're going to get a decimal for this number, it's going to be rounded and it may cause some inaccuracies. Probably not, but this is just a preference. So if we do shift tan of 3 over cosine 20, that is going to be beta equals to 72.6 degrees. So this first principal solution is 72.6 degrees. It's positive, that's why I moved counterclockwise. Okay, now what is my range over here? The range was 0 to 90. So beta must be between 0 and 90. So my first solution is accepted, okay, in my range. Now let's check for the second solution. If I want to find the second solution, I will start from x, positive x-axis as always, and then move counterclockwise. This is 180 already, and then I need a little bit more. By the way, this is going to be also 72.6. So this angle is 180 plus 72.6, way over my range, so I'm not going to take it. And if I continue from here to get the other, it's just gonna stay greater and greater, so I'm not doing any progress over here. If we try to get a negative solution, we move in the clockwise direction. So this is 90, we already exceeded 90, so this is also outside our range. That's telling me that the only value over here that I'm going to take is the 72.6, and this is going to be my final answer. Questions like these are tough. Questions like these require identities knowledge, require lots of practice. So I hope that you found this video helpful. Please feel free to suggest or ask any questions in the comment section down below. And I'm going to do full topic revisions for pure, a one-stop video, which is all you need for this exact topic. Let's say for sequences or for trigonometry or for so I'm gonna do like a long video going through what you need, no nonsense, just straight into what you need to solve, and then I'm just gonna keep solving lots and lots of ideas to cover most of the ideas, or if not all of the ideas on that topic, so you have all the tools you need in your test. So please, I hope this video was helpful for you. Don't forget to like and subscribe. Thank you so much for watching, and have a nice day.